All right, so we were discussing dielectrics, in which we found, that there are two types of dielectrics: polar and non-polar. Now let's get into the microscopic level. Why do polar dielectrics behave in a particular manner, or the non-polar dielectrics behave in another manner? Now, if you go deep inside a dielectric material, you can see that the molecule has dipole moment associated with it, which means if you look into the slides, you would find, for example, water, that there are dipole moments between ONH on both the sides, and then you can take the resultant of the dipole moment, right? So you see the arrow like this in the water molecule that tells you that water has dipole moment. So certain materials in nature have dipole moment. Now these become polar dielectrics, and certain insulators don't have a dipole moment, right? It cancels out. Let's look into another example of, for example, look at the example of chloroform. Like chloroform is also polar, and methane is non-polar, because in the case of methane, the left hand side, if you see, all the dipole moments are getting cancelled out. So the net polarity on methane is zero. There is no dipole moment available. So what will decide whether a material is polar or non-polar is the dipole moment. Get into details and you can get the answer. Thank you.